For the multiplicative decomposition model that I showed you, manual calculations, I'm going to show you how the POM.mp4 software will solve that problem. Here is the actual data. We have 5 years of quarterly sales. So 5 times 4, 5 years times 4 quarters is 20. And so we have 20 quarters of information. There is seasonality within the data. If I just solve it now, even though it's with the naive method, and go to graph, you will see that there's the black that you see is the actual time series. So you can see that there is great seasonality and there is somewhat of a trend. So we do need to use a seasonal model that accounts for trend. So under method, go to multiplicative decomposition. It'll generate these fields that you need to fill up. Number of seasons, we have 4 as the number of seasons because there were 4 quarters in every year. So the quarters are the seasons that repeat themselves. So I need to change this default of 1 to 4. Under basis for smoothing, the method that I showed you in my hand calculations is average of all data. It is not centered moving average, which is the default. Instead, it is average of all data. So I need to check on average of all data. And then over here, it's a seasonal factor scaling. I haven't talked about that. Generally, you want the seasonal indexes to average to 1. That means that when you add them all up and you divide by the number of indexes, you should get 1. So it averages to 1. In this case, they do. In some instances, they may not after you've computed them, and the reason being rounding. And so in that case, you would want to click that and say rescale set average to 1. But for now, I'm not gonna check that because we didn't do any rescaling of the data when we ran our analysis in hand calculations. With that, if I click solve, POM generates 4 results window for me. The first one is the forecasting results. That's where the summary or the vital statistics is. It tells you bias, MAD, MSE, standard error, and MAPE for the analysis. It gives you the regression line, or actually this is the trend line. It tells you that trend adjusted the trend adjusted forecast is 0.31 plus 0.92 times time period, and the correlation coefficient and coefficient of determination are also listed here. Future periods, these would be future forecasts for quarter number 21. That would be quarter 1 of year 6, or quarter 22, period 22 would be quarter 2 of year 6. So for several periods, future periods, the forecasts are listed. The 19.69 would be if you were to plug in 21 for time in the equation right there, and multiplied by 0.92 and then add to it 0.31. That would be just the trend forecast. But then the seasonal factor for that period is 1. So when you multiply the 19.69 times 1, you're going to get the seasonally adjusted forecast of 19.69. For this one, the unadjusted forecast for period 22, or for quarter 2 of year 6, is calculated as 20.62. The way it's done, you would plug in 22 over here for time, and you carry out that calculation and you would get 20.62. Then you multiply it by the seasonal factor for that period for quarter 2 and you will get the adjusted forecast of 11.54. So these are the adjusted forecasts in this very last column. The next window is the details and errors analysis. So you can go through this. Essentially, we've in prior videos that I've shown you, I've told you how all of these error, absolute error, error squared, and absolute percent errors are calculated. So we're not gonna go through that. Oops. The next window is tracking. It computes or reports the details of tracking signal calculation. And finally, the last window is the graph for this problem. The black line is the actual data. The straight red line that you see through, that's the trend line. The pink line that you see over here, I hope you can see it on the screen, that's the seasonally adjusted data. I'm sorry, that's the deseasonalized data. And the blue line, which as you can see tracks the actual very, very well in this problem, that's the actual forecasts of this model, which is seasonally adjusted and trend adjusted forecasts. So the blue line that you can see tracks so well with the actual black line is the forecasts generated with this model. Again, as you can see from the forecasting results, this is a pretty good model, and there is 94% 94% of the what happens to the sales of this particular piano or organ can be explained by the time passage of time that we have, or the information about time that we have, as well as the seasonality of the quarters. So that's how you solve this type of a problem using POM-QM. Thank you. I hope you have found this helpful.